Really quickly, I would like to summarize this video. Basically, I want to define what a ratio or a proportion is, and then we're also going to discuss how to graph ratios and proportions with the equation y equals mx, and we're also going to just go over some quick practice problems while I'm going over the material so that you can practice as you go along and learn it as we go. So hopefully this will be really, really helpful. You guys have been using ratios and proportions your entire lives. You probably just haven't realized it. So an example of something that is proportional is that it has two things that have the same ratios. Ratios can be anything, really. So we have a ratio of boys to girls in the classroom. So if there's 10 boys and 3 girls, we have a 10 to 3 ratio. If there's 10 boys and 5 girls, so that's 10 to 5, we can reduce that down to 2 to 1, which is pretty cool. And that's just the same way you would reduce a fraction, which you should already know. If you don't know that, let me know and we can get together and review that. Another example of ratio is a speed, right? So 60 miles per hour, you're going 60 miles every hour. So that's really awesome. You can use that to find out how far you can go in a certain amount of time, right? So if you have a half an hour, you can't go 60 miles in a half an hour if you're going 60 miles in a whole hour. But if we do that math, we can find out that you can go 30 miles in half an hour if you're going 60 miles an hour, which is something that you do almost every day, you just didn't realize you were doing. So we'll go over that math. Alright, so I just used the example of a car traveling at 60 miles per hour. So, now that you have that, I also mentioned that we could figure out from this ratio that the car can travel 30 miles in half an hour, okay? I know that this jump to that jump might look super overwhelming, but I promise it's not. We'll take it step by step. So like I said, this is a ratio. So in order to find how far, so let's say D for distance, the car can travel in 1/2 an hour, all we have to do is multiply 60 miles per hour times 1/2 an hour. And so that gives us that our distance is 30 miles. Now that was a whole lot of jumping, and probably didn't make a whole lot of sense if you don't already know that equation, which I haven't given you yet. So now let's take a step back even further, so that you can really fully understand this math that just happened. So the equation that I'm using is y equals mx, right? So when we use y equals mx, m will always be the ratio. Always and forever, m is going to be a ratio. Now, in this example, I know that y has to be my distance and x has to be my time. The reason I know that y is my distance and x is my time is because I know I'm trying to find how many miles. And if you look at the math that I did here, my hours had to cancel out. If it had been the other way, if I had been given the question, how many hours does it take to drive 30 miles, and the car is driving 60 miles per hour again. To show you how that would work, 30 miles equals 60 miles an hour times x. So then I'm going to do my math there. I divide 30 miles over 60 miles an hour equals x, which hopefully you already know the algebra behind that. So that's how you're going to get 1/2 an hour. And your units are basically doing the same math as your 30 over 60 is there. So you just saw how that math went both ways. Now let's go ahead and take a look at a couple of triangle examples here. So I just gave us two similar triangles. Two similar triangles. So something that we know about similar triangles is their sides are proportional. So in the previous example where we had 60 miles per hour over here, that was a ratio, right? Well, when I say it's proportional, what that means are the sides here have the same ratio, right? So this side to this side has a 2-to-1 ratio. Now this side to this side, 4-to-2, that also has a 2 ratio. Okay, so like I just mentioned, it's a 4-to-2 ratio, which is equal to 2. So you guys should all already be familiar with the concept of like a ratio from the Prezi presentation just before this. But just in case, quick reminder, it's basically two numbers represented in fraction format. And then I'm just reducing these fractions or doing the division here. And note, you have to make sure that you're always taking from the same triangle as your numerator and then the same triangle as your denominator. So here I'm using my bigger triangle there to my smaller triangle, and then again my bigger triangle to my smaller triangle. I'm going to do it one more time for my 6 to my 3 to also see that that's a 2. So that shows me that this triangle, or these two triangles, are proportional to each other. So what's really cool about that is I can use that proportionality to create another triangle that's similar. So what I mean is basically I see that 3 times 2 is 6, and 1 times 2 is 2, and 2 times 2 is 4. So I'm going to put these into my equation. Okay, so you can use this equation, y equals mx, to draw a third similar triangle. So the way you would do that is you would maintain things to be proportional with 2. So m will equal 2, because if you remember, m is always your ratio. Okay, I'm going to move the camera a little bit here. Bear with me here. Okay, so let's say we're going to have it will be similar to all of these, and proportional to each one. The way we're going to do it, so we're going to do x and y. So we're going to use our x values to be the same as these, so 6, 2, and 4. 6, 2, Now, if I have x equals to 6, y equals 2 times 6. So I just plugged m in for 2, or I'm sorry, 2 in for m, and 6 in for x. So then I just do that math. I see that y equals 12, 12. And then 2, y equals 2 times 2, and that's 4. 4. And then finally, 4 times 2. Sorry, I flipped that there, but that's okay because we know that the commutative property exists, so we can change our multiplication table around. So it's okay. So there's 8. Okay, so then to draw the triangle, this one would be twice as big as this triangle up here. So this side would have 12, this would be 4, and this would be 8. So that's not too terrible. So, and even to get even deeper into this, is that we can graph the equation y equals to mx. So I have some lovely graphing figures right here. When you'll do this, you'll do it online, but I'll label here, this is my y-axis, this is my x-axis, so x, and y runs vertically here. Okay, I'm going to come up here a little bit better. Alright, so 1, 2, 3, 4, 5. The rest can be counted by the person, but this just lets me know that you're counting by ones on your axes. So then we would look. 2 and 4. 2 is my x value. 4 is my y value. 4 is my x value, and 8 is my y value. So I go over 4, and then up 8. 6, 7, 8. And then something very similar to that, 6, and then up 12. 8, 9, 10, 11, 12. And then I would just connect them with a wonderful straight line. So, the cool thing about graphing, that should land on 0, 0. I just don't draw very straight lines. In this case, y equals mx is what we call a function in mathematics. What that means is the graph is a picture of all of our solutions for this equation, right? So if I am, a test of how straight my line is here. So 6, 7, 8, 9. Then this would be 18. Hopefully, if I counted right. 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. My line's not quite straight. There it is. That's the point. Sorry about that. If you're going to graph it by hand, I would recommend using a ruler. So, the cool part about that is that you can look at any point along here and say, okay, 7, that's at 14, and 8, that's at 16. And so that allows you to see all of the solutions. So in the case of the car example, if you were to do time along this axis and distance along here, and I said, how far can the car travel in 30 minutes? You just go 30 minutes, and find that line and say, it can travel 30 miles if it's driving 60 miles per hour. So that is why that graph is useful. Okay, so for the next one, we have triangles. with sides 5, 6, 7, and 15, 18, 21. And they're similar triangles, so they have their sides are proportional to each other. So I would like you to find their proportion. Here are your 3 choices. Please click on one that you think is the right answer, and it'll take you to another video that tells you whether or not you're right or wrong with an explanation. Okay, so now I've got another problem laid out here. You've got the triangle with the sides 3, 2, and 4, and you've got a triangle with one side that's 16, and it's similar to the first triangle. And I want you to find the length of sides A and side B. And I've got those 3 options, so go ahead and click right on your screen, and that will take you to the answer and its explanation. We started this lesson by discussing the fact that ratios and proportions are super life applicable. That can be used, when you double a recipe, or when you're calculating how much you're going to be paid if you're being paid per the hour, or how many hours you have to work to make a certain amount of money. Also, what I have written down here is, 15 miles to the gallon would be like gas mileage, so you can estimate how many gallons of gas you'll need to go a certain number of miles, or how many miles you can go with a certain number of gallons of gas. So I just love the life applicableness of it. So again, this is a ratio. If 2 shapes or 2 variable things have the same ratio, then they are considered to be proportional. Yeah. So we can represent the proportional items with y equals mx, where m will always be the same ratio that those 2 objects or relationships share. And you can also graph this equation. So in the case of the gas mileage, your x is your gallons, your y is your miles, and then you would label these with your units. And with this equation, your graph will always be a straight line. It will be slanted, it can be straight, it will never be completely vertical.